Welcome back once again. Today we're going to do a couple of things before we flip it over on the top and start putting in these this T1, T2 coils. But we have to do a couple of things on the bottom. I believe I mentioned it earlier. The local oscillator coil has a paper insulator between it and the chassis. Looks like this right here. A piece of crap, really. It's still held. I mean, it held up all these years. It's probably functioned just fine. But I wanted to change them and put plastic ones in there. But I've got the other two already done and the holes punched for these two. But this one here, I thought I'd hold off and show you how I do it. I just traced it out, you know, took one of these paper things, traced it out. I showed it to you earlier. And each one has two holes in it, as you can see. And I'm just going to take this old paper punch here and I'm just going to put it up there and get her up there, get the thing lined up where it's supposed to go, and get that baby and just punch that hole. Now let me go ahead and set that up. Here goes the first one. Alright, nothing to it. Then here goes the second one. Man, that piece of cake there. I like doing that. Well, there it is. Now, don't that look neat? Doesn't that look a whole lot better than this old nasty, old black nasty thing here, that old piece of cardboard? It sure does. By the way, in part 26, where I checked out the power transformer, one of my subscribers responded. His name is Norman Waltz. And he said that, he likes the audio on the videos now. He said he can hear my... I'll quote him. He says, "I can hear every pencil tap very clearly now." There you go, Norman. A few more for you. Next thing we gotta do is get that old heat shrink shrunk up around that resistor. The lead just wasn't long enough, and I had to splice a wire on it. All I have in the back is a piece of, I cut a sheet of paper. It doesn't take a whole lot. You don't have to worry about the paper exploding into a ball of flame just because you do a little heat shrinking. But by the same token, though, you don't want to keep the heat on there very long. Get your heat shrinking done and get out. You don't have to sit there until the paper turns brown. All right, another job done. Let's go back to the schematic for a minute, and what we're going to talk about is this 0.01 microfarad capacitor in the primary line that runs to ground. It's C17. Now I put a standard, 0.01 microfarad capacitor rated at 630 volts right here. And one of my subscribers said, shouldn't you be putting a safety capacitor in there? Well, let me clear something up here. Safety capacitors are nice to have and nice to install, but they're not mandatory. If you don't put one in, the radio's not going to explode on you, okay? Matter of fact, I could remove that capacitor completely out of the circuit and the radio would still operate. This thing is used, it's a noise suppression cap. Sends, noises to ground, and any spikes that come through will go to ground, thus protecting the primary on the transformer. That's basically all it's there for. So, safety caps are nice, install them if you got them, but they're not, it's not an all-consuming thing. Now, all that being said, Brendan said, "John, you need to put in a safety cap." I said, all right, I'll put in a safety cap. Well, I happen to have this is a Y cap. Look at the size of that thing, pretty big, huh? That's what we're going to put in there. We're going to put a Y cap in from here to ground, okay? Now this is an X cap, or actually I shouldn't say Y cap, I should say Y2. This is a Y2. We'll go ahead and put that from here to ground. This is an X2 cap. Now the X2 cap would go across the line from here to here, but we're not going to do that. We're just going to go ahead and put in the Y2. This thing is rated at 250 volts. I get these at justradios.com. I got a bunch of them here a while back. This is a 0.047. Even though that's a 0.01, it doesn't matter. We'll go ahead and put a 0.047 in there. And we're going to have, which means we're going to have to remove this one and put that one in. So that's my next job. Alright, the safety cap is now in. Some of you might be wondering, about these safety caps. You've never heard of them, never seen one, and you're wondering, what's the big deal? Well, the big deal is they're designed not to short. They're designed to open, and I'll show you where that comes in. You'll notice right here that the safety cap is now installed here. Now, eventually the capacitor would leak, and it would maybe short all the way to ground. Well, when that happens, what is ground? Well, the ground on this radio is the chassis. So picture this. Here comes the old electricity down the line, and it hits this spot right here. And, let's say it's leaking a little bit. Well, a leak is nothing but a small short. I don't care what you call it. Anyway, it'll leak a little bit and allow some voltage to go to the chassis. Then the rest, of course, would go through the primary and go back. Now a little time goes by. Now the cap is really broken down, and maybe it's shorted now. Now the electricity comes across, it comes down, and it's not even going through the primary anymore. It's going straight to the chassis because this cap is shorted. Now you've got what's commonly referred to as a hot chassis. Well, a hot chassis just means that it is electrified. You touch this thing and you know what would happen. We don't really want to go there. It would be quite horrifying, trust me. So now that we have a safety capacitor in there, if the cap breaks down or it gets hit with a very, very high voltage, the cap will open. It will not short, and it will not charge up the radio chassis. Well, that's about as basic as I can put it. It's a safe way for this capacitor to fail, if that makes sense. What do you say we go ahead and get these coils on finally, after a long time of waiting? Now the insulator, I had to cut off one side of it right here. Doesn't affect anything, but I had to shave off a little bit because it was these wires were in the way. I'll show you what I'm talking about. This thing here will go up here like that, and then it will match up with those holes just like that, and the wires will be clear to where they can come through that hole there. See? All the wires from T1 and T2 have been threaded where they're supposed to go and soldered up to the proper connections. Some of them had to go down below the chassis and solder up. Some of them soldered to each other. And some soldered to the tuning capacitor down at the bottom, like this blue one right here. Okay? That left us with a blue, an orange, and a black wire, which is what we're supposed to have. Those are our antenna wires. Since these are RF antenna coils, of course these are going to be antenna wires. We also have a black wire left over, which will go to the grid cap of the 2A7, which fits in that socket right there. Now the question is, how did I know where to solder up those wires, especially underneath here to the band switch and different places like that right there? How do we know where they go? See those flat bars at the bottom of each of these coils? The horizontal flat bars. They're used to secure the coils to the chassis. You'll note in the center that there's a screw coming up through the center. Well, not only do they secure the coils to the chassis, they do something else also. They help us with orientation of the coil, so we know, what position it's in relative to the schematic, what the schematic shows us. Let me show you what I'm talking about. Those horizontal bars at the bottom of those two coils, T1 and T2, correspond to these little flat things in the center here. Okay? Not only do they secure the coil to the chassis, but they also give you your reference point as to what pin is which on these coils. All right? For instance, pin number 1. Well, if you look at pin number 1, and you go up here to the schematic, you'll see that pin number 1 is right here. There it is on T1. And it says there's an orange wire connected to it. Pin number 1, orange wire. Alright, now over here, looking at it, pin number 1 would be at the top. We look over here and we see the orange wire is in fact connected to pin number 1. That's pin number 1 at the top, right there. Matches up exactly with what the schematic says. Now to the right is pin number 2. Pin number 1, 2, 3, 5, and 4. They're not numbered exactly consecutively. 1, 2, 3, 5, and 4. I wrote those larger numbers on the outside so I could see them easier. Now pin 2, what is pin 2 supposed to have on it? Well, if we come up here and we look at pin 2, we see that it's supposed to have a blue wire. A blue wire that goes down underneath the chassis and connects into that tab right there on the front wafer of the band switch. Blue wire. So now we come over here and we say number 2 is the one to the right. Clockwise. It'd be 3 o'clock. This would be noon. This would be 3 o'clock. So let's see what we got. Here's noon. We come around. Come around. And the first wire, but even though we have several here, the first wire we come to is this one right here. And look what's attached to it. A blue wire that goes down underneath the chassis. And it connects to the wafer switch down there. I'll bet it's to the front. What do you bet? There it is right there. Right there. Connects to the front wafer on that pin that it shows up there. And we've already gone through all of that before. So what I'm trying to tell you here is all you have to do is once you get oriented with what's on the schematic and you get that to coincide with what's here on the coils, it's simply a matter of following line by line, number by number. It just can't get any easier. It's just like a little puzzle, that's all. It's just like a little puzzle. You can do this. You just got to sit down, take your time, and work it out. I could sit here and show you all day how I did it. It won't do any good. You're going to have to sit down eventually and figure this kind of stuff out, because I know this looks like really complicated crap, you know, coming down, hooking to the band. Band switches always look complicated, but they're not. Instead of a pin here, you have a pin there. It doesn't matter. They're all soldered. They're just pins that, you know, have wires soldered to them. That's all. And they count around, and they count around. Each one has a number. Usually there's a number. If they don't have a number, go ahead and put a number on it. You can number these if you want. 1, 2, 3, 4, 5. And that way you keep yourself straight. Well, that's all we're going to do this time. Was kind of hoping I could get the rest of this stuff on the front here. You know, the dial, scale holder, and the gear and all that. But I don't want to rush it. You know, I don't want to push anything and wind up having problems. So I think what we're going to do right now is call this video done. And once again, I appreciate everybody tuning in. I hope I haven't confused anyone with how these coil hookup wires go. It's simply a matter of bouncing the schematic, numbered, you know, pins against what you have on the chassis, and then from the chassis back up here to the schematic. Back and forth, back and forth, back and forth. That's the only way to do it. So until next time, this is John.